Hello students, this is an overview of your midterm. It is assignment 7, and what we're doing here, this is the assignment directions. So please go ahead, read the assignment 7 notes, go ahead and read the directions, and also you are given a template. Even though this is the midterm, you are given a template. Now I'd just like to kind of give a pictorial, first of all, overview of what needs to be done. So the application is that of a radio jockey, right? And what we are going to do first is we are going to create a database of songs using linked list. And you know that you have designed this linked list class already. So the first thing that we are going to do is populate this database from this songs data.txt file, right? So the songs data.txt file, and then create a linked list called list. There are some changes that need to be done to this linked list ADT, to the abstract data type. You will use, the template gives you all the code that you need, and a lot of the methods, in fact 99% of the methods are already implemented for you. The changes are, we are going to add, in addition to a front pointer, we will add a back pointer. And we will see why we need the back pointer. The second thing that we need to do here is add a move method. You have an insert method, you have a remove method, an insert adjust method is also provided here. An insert remove method, adjust remove method is collapsed into a single method. So all of that stuff is already done, but you do need to add a move method, right? And the back, you will notice that a back pointer has been added to the linked list class. Now, so this is step 1. Step 2 is we are going to have this database. That's the first thing. We're also going to use the same linked list database, linked list class, to create a queue. This is going to be a lot like stack inherits from linked list. Queue is also going to inherit from linked list. What is the meaning of inheritance? The meaning of inheritance is that it will basically, like it means in regular everyday language, it's going to have all the member fields and all the functions and the functionality of a linked list, but a child class has the permission to add more functionality or modify the functionality, right? The functionality that the queue is going to present is it's going to allow you to add an element to mimic the behavior of a queue, to add an element to the back of the queue. So you see why the back pointer becomes useful. And then to remove an element from the queue. So removing from a queue is just like a grocery list. You're going to remove from the front. And then the other functionality is check if the queue is empty or not. These are the only 3 methods that you will be asked to implement in the queue ADT, which inherits from the linked list ADT. Now, the way you will implement add and remove is by using functions that were already available in the linked list ADT. So add, if it's adding to the back, then you're going to make use of some of the code that's there already existing, right? And remove, you can use some of the code that already exists in the linked list class. So now I'm going to clear this using the array. So this is what our application is going to look like. We have a songs database, which is all the same songs that you've seen throughout this application. And then what we have is the radio jockey gets requests, which could be from people who are requesting him to play songs, or it could be admin requests, right, to add a song to the database or to remove it, or to move a song from chart position 100 to chart position 1, and so on. So since the RJ cannot be interrupted in his work, he makes use of a request queue. So a request queue contains requests, and a request class has been already provided and given to you. What a request looks like is each request consists of a song with, for example, the title of the song, the singer of the song. So we don't have to go and look at a completely new structure, but we will stay with the strong structure, song structure. But the thing that gets added to a request is an action. And this action is a character, which is either A, add, remove, play the song, play top 10, or move the song, right? So move the song would move it from this position in the database, right? Or play the song. So basically these actions in the queue tell the RJ what to do from the main linked list database, right? So these requests, they form a linked list, which is a queue. And as the requests come in, they get added to the back of the queue. So the queue grows in this direction. And the queue then, once the RJ is able to catch a breath, he or she is going to pick up an element from the front of the queue, process this, and then a processing could be add a song. So he would go and add a song, remove the song, go ahead, remove the song, play the song. So he or she is going to go and play the song and basically process all of these actions. Once they're done with that, they're going to delete this element from the front of the queue. So remove from the end of the queue, right? So this is the overall overview of the application. So we will have two linked lists. The first linked list is the database. The second linked list is going to be the request, and there's going to be a request class. This one is going to be a linked list of songs. This one is going to be a linked list of requests. And this is actually going to be a queue, which means you can't have all the full functionality of the linked list. The only functionality that a queue offers is add, remove, and check empty. The other thing that I'd like to point out that is a new feature, but a very important feature in data structures is that of the iterator. An iterator has been provided for you in the linked list class, and it's a struct. So it's got a constructor, and it's got a lot of functions inside it. One of the important functions, an iterator is an object which contains a pointer to a list node. What's a list node? A list node is basically a component of the linked list. So what we will do is we'll have an iterator that points initially to the front of the queue, and you can have the iterator move along and traverse. So instead of using an index, what we are going to do is we are going to use an iterator that moves and traverses from the beginning to the end of the linked list, or in this case, the end of the queue. And iterators are given methods begin and end. The begin returns a pointer or an iterator object to the beginning of the queue. The end returns a pointer to the end of the queue. And then operator, then we also have functions like plus plus, which have been overloaded to increment the pointer from one queue object to the other, right? So, and also you've been given a star operator, which has been overloaded to dereference the iterator. So when you dereference the iterator, you're actually accessing this element inside the queue. You do not need to write any of these methods. This is for your understanding of what the iterator is, but iterators are extremely important in data structures. So this is part of your learning, and you will be asked to use the iterator to iterate over the queue. So get an element, process it, move the iterator to the next element, process the next element till you reach the end of the queue, right? So this is going to be what you will be primarily doing in this midterm assignment. So now what I'd like to do is I'd like to scroll up. I'd like to scroll up and show you your assignment. So there is a lot of explanation about the request class, the linked list class, the queue class. Now here I'd like to point out to the UML, which describes to you the queue data structure and the three methods that you need to write. Here is the request class that's completely given to you. You do not need to write it. And the instructions for what you need to do are also given. So you will also work on methods in the linked list class and specifically add this method, i.e. the move method. The iterator is completely given to you. There's a reference to Geek for Geeks where you can read more about iterators and their functionality. The instruction is that read these and here's what you need to implement. Implement the move method in the linked list class. Implement the methods of the queue class, which have been given to you right here, the three methods. And also implement in the main program, in the driver, implement the process requests, which again, declare an iterator and then move the iterator so that it traverses the queue and processes the request, i.e. PMART, and a lot of that code is also provided. So scan the template to find what you need to, what are the to-do elements, right? Then you're familiar with this by now. So the driver creates an empty song base, an empty queue. It calls the populate database method. This is given to you. It prints the sorted database. It calls the populate queue to fill the requests from the request data file, which is request_data.txt, prints that queue, and then process the queue from the front to the back of the queue using the iterator. And it calls these methods add song, remove song, move song, etc. And then it prints the resulting database, which is the final result after all your processing is done. I'd like to show you the template that's given to you. As you can see, there are a lot of files, but a lot of these files are familiar. It's the same song.h, song CPP, songs database, only this one. And then there is request.cpp, request.h. All of these are given to you. The only new one that's popping up here is the queue ADT. And here is the to-do. You're expected to write these three methods as mentioned. The output file is also given to you. What is going to be the expected output? The list node class is given to you. You do not need to write it. The linked list class is given to you, but as you can see, I have added a back pointer to help when you create a queue, which is also a linked list. And all of these methods are given to you. The only method that you need to write, and there's a to-do right here, is the move method. The one thing I'd like to point here with regard to the linked list class is the iterator, and all of these methods relating to the iterator are given to you. So here they are. The iterator methods have been completely up. So I would just like for you to take a look and see how I have accessed the iterator from inside the linked list class. You see, it's two sets of colons to work on the scope of this. All right. Now, one thing before I forget, I would like to show you is that at the end, I have asked you to write a reflection. And this reflection is worth 5 points, but it's a very important activity because it directly deals with your understanding of data structures. Is how does an iterator improve efficiency of operations in a queue? I'd like you to give the answer in a big O notation format. And how does having a back pointer improve efficiency of operations in a linked list queue, and specifically which operations are affected? So this is something that as you do your assignment, I'd like you to think about. And then going back to this, to the main program, you see, the main program is given to you. A lot of the methods, the populate request method, which populates from the request data, this is given to you. The play song method is given to you. The print top 10 songs is given to you. And this add the song, remove the song, and move the song are the methods that you need to add. And process queue method, process request is given to you, but process queue is what you need to write by calling the iterator, right? And a lot of this information is, there's a lot of comments which will help you. Populate database is given to you right here. This method is given. So, all right, so good luck, and I will stop the video right here.